Hi lads, we've gone through most of rates of reactions now. I just want to briefly run through a couple of things and then hopefully what we'll have at the end of this is effectively we'll be able to have a test on it. Now how we'll do that test we'll figure out as we've gone through. Measuring rates is something we did before we left. That's measuring either the decrease in the amount of one of the reactants or the increase in the amount of one of the products. Whether that amount is measured in terms of mass or in terms of volume, you know, the gases, that would be in terms of volume, and then the mass, it would be in terms of a decrease in mass of the reactants. And normally what you would do there is put things in the mass balance. I'll show you that in a second. Factors that affect the rates of the reactions, I've sent you a video today and you look through those. We'll briefly go through them today and now with you as well. And then the kinetic theory and activation energy is something very straightforward as well. That is just the idea that molecules must come in contact with each other. And then activation energy is essentially, we said this before, like they must come in contact with each other with sufficient energy such that they break the bonds within themselves. We looked at most of this already, what the rate of a reaction is, change in concentration per unit time. Do you remember just like speed, distance per time? This is either change in one of the reactants or one of the products. Just be careful about that. I'm going to breeze through this first bit because it's what we've done before we left. The average rate of the reaction, like that's the total change over the length that the reaction occurs, or from time 0 to whenever you stop the clock effectively, over the time taken for that reaction to end. So don't forget that the average rate, it's a bit like the average speed between here and Athlone might be 100 kilometers an hour, but obviously you don't leave the school here and reach 100 kilometers an hour instantaneously. The speed goes up and down as the journey goes along. Likewise, in the rate of a chemical reaction, it goes up and it goes down. Almost like the same type of thing if you were to leave one town and enter the other. The only difference is at the start of the rate of a reaction is it's incredibly fast, but then it does gradually go down as the time goes along. Measuring the rate, this is the reaction that you did beforehand. Please don't forget to always include the stopwatch because obviously we need that to show. Here, this is called the downward displacement of water because as you collected the oxygen there, the water is forced downwards, and when something is moved, it's considered to be displaced. We just use tubing here, which is perfect because this glass tubing breaks very easily. And then the manganese dioxide that is here, that black solid acts as the catalyst. The catalyst obviously alters the rate of a reaction without being consumed itself. That's the big difference for leave insert. You say that the catalyst alters the rate rather than speeds up or slows down. So just be careful about that. This is the experiment you did, and then you drew those results. You got those results. The instantaneous rate, to calculate that, you really need to draw a graph of the reaction. And leave insert chemistry, that's how we do it. So you've done this already, we went through it, so I'm just revising this again to try and bring this chapter together for you. You plot all the points, so you'd have times 0, 5, 10, 15 in terms of seconds, and then the amount of off. You have loads of dots here. This is a scatter plot. X value, Y value, both of them are changing. Time is obviously changing, you can't stop that. And then the concentration or amount of product, obviously concentration changing would indicate an increase in the amount. And then if you want to know the instantaneous rate, that's the rate at a particular time. Here, it would be this point here on the graph. So say this is 5, 10, 15, 20, 25, 30. That's at 30 seconds. Draw a straight line up and touch the graph. You don't really need this yellow line, but you just need to know exactly where that point is there. Then you lower the ruler down such that it drops just to that point.